A painter sections a 60-inch by 130-inch canvas into a grid of squares to be painted individually. The question is, what is the largest square possible so that all are of equal size and no overlapping or cutting of any region occurs? So we want to establish a couple of facts that are going to help us determine the answer to the question. So the first thing we know is that the painter is going to put a grid of squares over the entire canvas. So that's an important piece. We know that the squares in the grid cannot be different sizes. They must all be the same size. And remember that a square is equal sides. The length is equal sides, so the width and the length are equal on a square. And the squares are going to be put in a grid style onto the canvas. So, since a square has equal sides, we want to make sure that the number of squares we put in must equally divide into our canvas, which is 60 inches and 130 inches. Alright, so the way that we do that is by using our greatest common factor. So we're going to want to factor out both of our numbers here, 130 and 60. So 130, the factoring on that is 2, 5, and 13. And we can prove that by doing our little tree, and we have 2 times 65. The only thing we can do with 65 is 5 and 13. So 2, 5, and 13 are the factors for 130. We also want to factor out 60, and when we factor out 60, we get 2 squared, 3, and 5. And we can prove that with a factor tree of 2 times 30. 30 factors into 2 and 15. 15 factors into 3 and 5. So we have 2 2's, which is 2 squared, a 3, and a 5. Now our goal is to find the greatest common factor. Remember that greatest means biggest, and common is a really important word here because that means that they have to be the same, or they have to be common between the two numbers that we're factoring. So we have 13. 13 works for 130, but we don't have anything there for 60, so it immediately goes. We have 3 in 60, but we don't have that in 30, so it goes. Aha, 5. We have 5 as a common term, so we can put 5 down as a common term. And we also have 2's that are common, but one is 2 and one is 2 squared. In this case, we're only going to use 2 because this is basically 1 2, right? 2 to the first power. And that second 2, the second 2 to the second power, doesn't have a common term in 130, and so we're only allowed to use one of them. So 5 and 2 are the common terms in 60 and 130. Once we determine what our greatest common factor is, we take those two numbers and we multiply them. So our answer is going to be 10. And just like that, we have the answer. The question was, what is the largest square possible so that all are equal size and there's no overlapping or cutting of any of the regions? The answer is 10. So if we take a square that's 10 inches by 10 inches, we'll be able to put 6 of them in columns and 13 of them in rows, and it will be able to cover the entire portion of the canvas.